Well, yeah, good afternoon. My name is Brett Raybould. I run the SE team for EMEA for Menlo Security. Delighted to be here today in person, first event in 2 years or so. Don't know why I wore a light blue shirt to Manchester, but yeah, what I'd like to discuss over the next few minutes really is just around some of the synergies that we're seeing around Zero Trust, around SaaS or SASE. We offer some unique benefits in this space. Hopefully I can highlight those and show you some of the value that we're providing to our customers. So to begin with, really the why, the driver for the whole SASE movement. You know, surely it's been accelerated based on the changes, the challenges that we've all been facing with the pandemic, the changes to the operating systems and the way that we design networks. You know, we were moving in the same direction, albeit, you know, at a much slower pace. But essentially, services, applications, systems, platforms, they've either been moved to the cloud or they're being moved to the cloud. So having that centralized, you know, perimeter of everything security-wise, you have a funnel at your central office where all your stack is, that sort of thing, routing everyone's traffic back in to then go out to the internet, fundamentally doesn't really make sense anymore. So the idea being that, you know, the perimeters are now distributed, the data is distributed, and users are distributed. Everyone's working from everywhere. I saw a quote in the program from the gentleman before me that was saying that the activity is the new perimeter. I thought that was really good. But essentially that means that we have to change. So we have to change the placement of our security tools and products and services to give the same experience to users regardless of where they are or where they're connecting to. So SASE itself, you know, it's moved a long way, it's come a long way, but it's not going to protect you from all the threats that are out there currently. So what we have at the moment is we have a convergence of a number of different technologies that we're essentially moving to the cloud. So those same systems and services that we were traditionally running on premise, but one of the things that we're seeing is that, you know, the two biggest attack vectors for organizations is still web and email. That is exacerbated by the fact that users are essentially spending their entire day within a web browser or within web-based applications or services or platforms. So web browsers, you know, despite the huge amount of investment that everyone's doing from a security perspective, is still the low-hanging fruit for the attackers. All of them are using different rendering engines, but we're seeing vulnerabilities being created or discovered by attackers and exploited for, you know, a huge increase, essentially. So, you know, today, how have we really been dealing with this? Well, education as a start. We have to try and, you know, educate the users. You know, don't click links. Think twice before you enter your credentials. You know, look for the signs and signals that you might be in a situation that could be phishing or something like that. You know, something out of the ordinary. But, you know, the chain is only as weak as its weakest link, unfortunately, which is a lot of the time the users. So we've been following Gartner and whoever else's adaptive security modules or architecture around layering of detection-based controls. So systems which are very clever, which are very useful, they're being layered so that if one misses each other, you know, hopefully one of the layers is going to catch it. It's all very useful, but, you know, as I'm certainly not going to name and shame, but, you know, as the media is showing, you know, the attacks are not slowing down. The attacks continuously happen. It happens via email, phishing, web, you know, inadvertently coming across infected advertising servers or whatever kind of drive-by type of infection is happening. All of these systems, whilst they're all incredibly clever, very good at what they do, they simply suffer from three limitations. One is that they're all prone to making mistakes. So false positives, false negatives, they miss security events and they misclassify security events. The second is that they're typically noisy. So they'll create a lot of alerts that your security teams or your operations center has to analyze, triage, remediate. They have to try and determine which are real alerts and which are false positives. And that takes time. It takes time away from the SOC. It takes focus away from the SOC. And the third one is they're incredibly expensive to maintain, to deploy in layers on top of each other, and then to operationally run on a day-to-day basis. So SaaS itself, we're essentially moving these controls from the network to the cloud, so that when users connect to those applications and services that are on the internet, if they're connecting from home, if they're connecting from Starbucks, the airport, your branch offices, they can connect directly. But one of the things to bear in mind is that these controls which we're moving to the cloud, they're still the same controls that we've been using on premise, and they're still the same controls that have the same limitations that we were previously living with. So simply following a certain architecture and moving these controls with that architecture to the cloud is not going to plug the holes that it wasn't plugging when it was on premise. Although it does go further to connecting users, gives a much better user experience, that sort of thing. I forgot about that one. So essentially, that's where our zero trust comes in. So at this point, we've moved everything to the cloud. Everyone can connect from anywhere. The network security, or networking, or network as a service side of things is, sorted. The other thing with zero trust, which I can see from the program, it's been covered in detail, so I won't go over it again. But from a high level, we're essentially starting from a point of implicitly not trusting either the entity that is connecting to your data, and if we do grant trust, we're going to continually reevaluate that. So that essentially you have to prove who you are to be able to then connect and access the data. If your machine or your behavior starts becoming out of the ordinary, your machine's over here, but your phone is in a different continent, but you're all connecting to the same thing, it looks like you're being compromised, then your trust is going to be revoked and you can no longer access that sort of thing. So, this is great. So this is essentially protecting the data from your users. If your users are trying to access the data but they shouldn't have access, or they shouldn't be able to access the data with least privilege principles and all that sort of thing, zero trust would work for that. But what zero trust doesn't do is it won't protect your users from the data itself. So the opposite way. So if your user can connect to a file server or connect to the system and authenticate and then grant access to a file server, call it Dropbox, they download a file, but the file is infected. The user would have no protection against that other than what is the rest in the stack, which we know is not completely accurate. So one of the things which we have been trying to implement was that bi-directional zero trust. So starting with implicitly not trusting either direction, either from the data coming to the user or the user going to the data. And this is essentially what Menlo Security does. So the way that we do this is by inserting this isolation platform or secure layer where we can move the execution point for content away from the user and into a secure environment. So essentially, we're creating an air gap between the user and the internet. So when your user would start to browse, say CNN, they browse to CNN, they would connect to CNN, they connect to all of the third-party systems, servers for advertising, for content distribution, for tracking, social, all of these background requests that are happening. They pull all that content into their browser, and they execute that content in their browser to build up this document object model, which then displays to their screen. So the bit that we're saying, hey, it doesn't really make sense anymore, is downloading all of this content onto your browser and executing it in the very environment that is going to be attacked if there is some sort of malicious code. So what we do is we move the risky phases of browsing away from the endpoint. And the way that we do that is we use essentially two different things. So firstly, the crazy colored purple boxes in the middle with the fetch and execute. These are things called disposable virtual containers. So cut down Linux-based operating systems, which are hardened. We've got a whole bunch of different controls to ensure that nothing can escape these virtual containers. So your user request comes in, we pair them to a container, and then within the container we're running a Chrome browser. So we run this browser on behalf of your user so that we connect to CNN and all the rest of it. We pull the content into the container, where we execute it in our container, build up the web page, and then we use this patented technology in the luminous green section over there called adaptive clientless rendering, which allows us to then synchronize the document object model from the container down to the user. So what it actually means is users receive text and they receive sanitized resources. So things like images, fonts, CSS files that say, hey, this should be red, this should be blue, this is how it should be laid out. If someone, an attacker, has tried to embed some sort of code into these resources, that gets stripped out before the user receives it. So the user receives what, to them, looks and feels like they would have received by executing that content locally, but none of that content is being executed locally. So that's all in the cloud. So the other things with the containers is that they're session-based. So as soon as you browse to a different domain or you close your tab, we shred those containers. So there's no data from that user's browsing session which is residual on our platform at any given point. So nothing from the user's browsing data, no sensitive information, no passwords, no usernames, anything like that. So all of the browsing data gets destroyed. We start from a clean slate, and then we just pair you to a new container for your next request. So this allows us to essentially provide that bidirectional zero trust. So your user doesn't trust what it's connecting to. It's protected from the data, and the zero trust around accessing the platform would happen before this sort of process is invoked. So Menlo as a company, we've been around for about 2013 we got founded. We're firmly in that SASE space. So we do secure web gateway, we do CASB, we do data leakage protection, we do private access so that you can publish those applications that you might be running on-premise to users without requiring them to have VPN or any kind of access into the organization. But the thing that sets us apart from every other vendor that does the same thing as us is our isolation core. So this is our zero trust access or methodology that we use for security that is really at the kind of the beating heart of everything. So we use this within and throughout all of our products. So everything is done centrally in terms of management, in terms of reporting, in terms of visibility. The controls are embedded into all of these modules, which you would run from the cloud. So we typically deploy this as a cloud service within Amazon Web Services. We can automatically scale based on traffic thresholds and all that type of stuff, so that each of these components are essentially virtual machines. If more capacity comes in, there's a traffic spike or something like that, we can just automatically deploy more. But the main kind of USP, if you will, is using this isolation core. So it doesn't matter if your users are browsing the internet. They get isolated, so we do the remote browsing on their behalf. If they're clicking links or they're opening attachments, we extend isolation to documents. So similar to web browsing, if a user were to open a document, a Word file or a PDF file or anything like that, we'll pull that file into the container, extract all the contents, we build that content into HTML5, and then we securely serve that to the user. So the user gets this kind of copy of the original document. If there was something malicious embedded in the original, that's on the outside of the bulletproof glass. So there's policy and controls embedded in to provide access to all of these types of data through all of the different services and modules and that sort of thing, which is provided through our platform. But then we do also embed those traditional controls, like URL databases, like antivirus or sandbox and that side of things, so that if you have to break the glass and provide access to original files or content or data for business purposes, then we'll still pass it through those traditional detection-based controls. I think I'm pretty much coming up to time, but hopefully if I can leave you with something, the message really is just that, if you're thinking about SASE, you're thinking about zero trust, from our perspective, having a combined, unified solution that incorporates both of those architectures is really where our customers are seeing the most benefit and hopefully yourselves would as well. SASE is great. It's providing that additional benefits and security around architectures for providing access to the internet from anywhere, from everywhere, from wherever your users might be. And Zero Trust is moving away from that detection-based model, which is trying to essentially figure out is something malicious or is something not malicious, and unfortunately making some mistakes as you go through. So as I say, having a combined solution is really where we see benefit, and hopefully where we can give you guys some guidance. If you are still around later, love to talk to anyone. We're upstairs as well. Thank you very much.